Hi, I'm Willie Hartman, design lead here at LumaField. Today, I'm going to be talking about custom views in Voyager. These are different tools that allow you to get deeper into your data, whether you're looking at 2D slices or at the volume itself. This includes crop, region of interest, and custom slice plane. Each of these will let you get a higher fidelity visualization of different parts of your part. To start, I'm going to take a look at the crop tool on this fiberglass filled ball valve. I have the reconstruction selected here in the data panel. This allows me to see the attributes here on the right, and the first attribute is actually the crop attribute. So to crop this object, I just need to enable the crop attribute as well as show the bounds. The bounds are just the controls. So anything that is inside this prism will be rendered by Voyager. If I pull the handles, you can see that I am actually adjusting not only the bounds, but I'm actually cropping the object live. This lets me get inside of the part and see deeper features, say this screw feature here in the middle. And if the bounds are blocking the object itself, I can actually disable them. So this is a really simple feature. You can use this to create live visualizations, but this will not persist unless you make a bookmark of it. This is just a really easy way to do a live cross-section of any object. Now we're going to move on to regions of interest. Regions of interest allows you to request a high-resolution volume of a certain portion of your larger reconstruction. This is because we cannot display the whole thing in the browser. It's too big. So this tool allows you to get the highest resolution data of a small portion of your part. We're going to look at these AirPods and isolate a specific portion of them and request the region of interest back. The region of interest tool is very similar to crop. You're going to want to select the reconstruction that you want an ROI of, and then in the toolbar, you select ROI. So in this case, I'd actually like to get a aligned and a higher detail version of the PCB here on the neck of the AirPod. So to do that, I want to show the ROI volume as well as apply the crop so I can preview what I'm going to receive back. Then I proceed to dial in the parameters of the ROI. And so what I'm going to want to do is I'm going to just want to cut out everything except for the part that I want to see. This tells the back end that it just needs to give me the information in this volume. So I mostly have the neck selected here, but you can see it's not lined up. And so I'm going to want to actually move to a 2D view so that I can start to refine my ROI input here. So as you can see, I'm using the crop box here as a reference to line up the PCB line here. While I'm doing this, I can go back to the reconstruction and I can actually change the visualization settings so that the preview of my ROI is a little bit clearer and easier to see. You can see that from this angle, we're still out of alignment. So I need to rotate. And as all I'm doing is trying to minimize the amount of wasted space in this operation. This also lets me get a very precise read on exactly how lined up I am to the ROI reference frame. You see when I start scrolling through the slices here, the bottom of this PCB comes in first. So we're going to want to rotate it a little bit more so that we can try to balance that so that this returns a perfectly aligned ROI. And this will allow you to slice through at perfect cardinal planes. So that's about good for now. Once I'm happy with that, I'm going to click Submit. And as you can see, it immediately starts loading the new ROI. It has returned. And so let's take a look at that. All right, as you can see, the new ROI is just the isolated portion that we requested back, and it's at higher resolution. In addition, you can see that the slice planes are pretty well aligned to the directions of the PCB. So this means that if we're slicing through any of the primary axes on this object, that they'll come through lined up properly. So that was the ROI tool. It lets you get back any area of your part in higher resolution right in your Voyager project. So now I'm going to move on to custom slice planes. This is similar to the other features in that it allows you to make your visualization match more precisely a physical feature on your part. In this case, it lets you slice through your part at any arbitrary angle. This is very helpful if your scan is not aligned to the cardinal slice planes that comes in by default. So we're going to look at a plastic gear and see if we can line it up and slice through it very precisely. So this is the gear. You can see that by default, the gear is not aligned to the slice planes because when we look at a slice plane, you can see that it's not proceeding through in a flat way. To visualize this even more clearly, select your reconstruction and toggle on Show Slice Planes. In a 3D view, you can see that the slice planes are at strange angles compared to the part itself. And so what the custom slice plane does is it lets you make a new slice plane that you can orient however you want and lets you slice through your part very precisely, even much more precisely than the default slice planes. To make a custom slice plane, select your reconstruction in the data panel and then click the slice button in the toolbar. By default, the custom slice plane tool has some parameters that need to be adjusted. You can see that it's nested here under the reconstruction. You want to turn on Show Slice Plane, and the bottom two toggles are mutually exclusive, so only one can be on at a time. To start, set your slice depth to 0. This parents the rotation gizmo properly to the slice plane. I'm going to turn off the slice planes of the parent reconstruction. There we go. Now I can just see the custom slice plane. In my second panel, I'm going to change to A. A is the name of my custom slice plane. And so now if I move this, I can see that my visualization is updating. I'm going to try to slice through this part along the primary face, so along the top edge of the gears here. Start by eyeballing the alignment. After you've eyeballed a rough fit, move to a portion of your part where you can see whether your plane is in alignment. The top of the gears here, you can see that the top edge is a little bit off because this is dimmer, this is brighter. Clearly, this is not perfectly aligned. By having the split screen open, you can make live adjustments and dial in that custom slice plane. We're pretty close, but let's try a few other areas of the part. You can see right here that we're still a little bit off. There we go. That looks pretty even. Once you're slicing evenly through your part, you're going to want to move your custom slice plane to the beginning or end of the area that you'd like to slice through, and then you can set the slice axis length to a reasonable distance for your application. At that point, the slice plane will behave the same as any of the others, and the UI and the viewport will be able to control it. So now we're slicing through the part from back to front, but let's say, because it's a cylinder, that we actually want to rotate the slice plane radially around the center of the axis of the part. You can achieve that with the custom slice plane by moving the slice plane to the center of that axis and then using the rotate gizmo as opposed to the slice handle to rotate radially through the part. So let me move the slice plane up here to the center of the part so that I can see what I'm working with. Let's move over to rotation and let's grab one of the handles and pull the slice plane 90 degrees in one direction. It's a little bit tricky to get this exactly right, but if you can get your custom slice plane to be almost exactly in the center of this axis, then when you grab the rotation handle, you can see that you can radially slice through your part. You'll be able to see if you're off a little bit if you translate your part and you see that there's a little bit of a wobble. You see how it wobbles back and forth there, that means you're off. But if you're exactly in the center, there won't be any wobble in the center part of your slice visualization, and you're slicing through your part almost exactly in the center. So those were a few ways that you can use custom slice planes. You're going to want to bookmark custom slice planes, your regions of interest, as well as your crops so that you and your collaborators can see the same thing. These custom view tools will allow you to get more insight out of your CT data using LumaField's Voyager software.